Hello team. In this video, we're going to talk about VXLAN as an example technology that we can use to build virtual networks. So we've discussed VLANs before. So here we have an Ethernet packet, and an Ethernet packet is made of a destination and then a source, that's the destination address, the source address, and then there's a type of packet specifier, and then the payload. And up here we have an Ethernet packet with a VLAN tag. So we have again the destination and the source, and then the type, and then the payload. But in here we have this little, V, which is the VLAN identifier. Now, one problem with the VLAN identifier is that it's only 12-bit long, so we can only have up to 4,000 virtual LANs. While 4096 virtual LANs is enough for most local deployments, it's definitely not enough for a cloud environment where there may be thousands of tenants with tens or hundreds of thousands of virtual networks. So 4096 is definitely not going to be enough. So in the cloud, we actually use other technologies to virtualize networks. And one possible technology is VXLAN. So VXLAN is a little bit different from VLANs. So instead of tagging packets, VXLAN uses encapsulation. So here's our original Ethernet packet. When a virtual machine sends an Ethernet packet, VXLAN will take this original packet and put it into another packet. So here we have our packet. It's now the payload of this bigger packet that contains this VXLAN header. So the VXLAN packet has a destination, a source, and a type. So this is part of the Ethernet header. So it's the same thing that we had in our original Ethernet header. So we have destination, source, and then the type of Ethernet packet. And then we have IP header, an UDP header, and then the VXLAN header. So it's a lot of headers, it's a lot of bytes, and we have enough space to be able to generate millions of VXLANs. And these headers are totally transparent to the virtual machines that are sending packets. So our virtual machines think that we're sending Ethernet packets normally, then this encapsulation and decapsulation using VXLAN is performed by the network. So let's go over an example to make this concept a little bit clearer. So here we have a virtual machine VM1 and it's sending a packet to VM2. So it sends this packet on the virtual link. Then the switch will receive this packet. The switch sees that the packet is destined to VM2, so it can just deliver the packet locally. So, there's not much work to do here. We just send the packet to VM2, and then VM2 receives the packet. So, and the switch ensures isolation. Now let's consider that VM1 wants to send a packet to VM3. So the switch will receive this packet, and then it sees that the packet needs to go to VM3. But we don't have enough VLAN tags across the data center to use just VLAN. So this switch is configured to use VXLANs. So it's going to take the original packet and encapsulate it into a bigger packet, and it will add the VXLAN headers to this packet. So now the source of the packet is server 1, so this server is sending the packet. The destination is server 2, so this server will receive the packet. And the VXLAN is the blue one, right? Because VM1 and VM3 are on the blue VXLAN. So this is, they belong to the same tenant, they're on the same VXLAN. So we send this packet over to the fabric. So it goes on the wire, goes on to the next switch, and then this next switch knows how to route the packet. It needs to send a packet to server 2, right? So this is the destination. So the switch will send the packet on the wire, server 2 will receive the packet, and now sees that it's a VXLAN packet and it's on the blue VXLAN. So it will remove the VXLAN header, and then it knows that this packet is destined to VM3 on the blue VXLAN, and then it delivers the packet to the correct VM. So this set of operations is performed by the network, and VM1 just thinks it's talking directly to VM3 without needing to worry about this encapsulation and decapsulation.